Welcome friends, welcome you all in my channel Chemistry, the Mystery of Molecules. I am Tanmay. I am currently doing PhD at Indian Institute of Science, Education and Research, Kolkata in Chemistry. So, if you like my videos, please subscribe my channel. And today we are going to learn about directed ortho-Metalation. Last day we have discussed about the reagent which breaks the aggregate and controls the reactivity. For example, diethyl ether, THF, TMEDA and HMPA. So today we will check the uses of such reagents for selective lithiation followed by electrophilic addition on aromatic ring. So let's start. So directed ortho-Metalation. So from the name you can understand it is ortho-Metalation, ortho. Okay. Actually, since we are talking about lithium attachment, then actually directed ortho-lithiation. So this reaction is called DOM reaction, directed ortho-Metalation, DOM reaction. So what happens? This metal, for example, here lithium is added here. And since lithium contains alkyl group, for example, if we use lithium, alkyl lithium, then it selectively abstracts this proton, and actually what happens, this anion goes to lithium and this alkyl abstracts this proton which results in directed ortho-lithiation product, that is lithium, this X and butyl. So the first criteria of this directed ortho-lithiation is that this attached metal should have a coordinating side, means it should have a lone pair that it can coordinate with the metal, and then this after coordination attack will be selectively on the ortho side. Please remember here the reactions all are kinetically controlled. In fact, butyl lithium reactions, means direct butyl lithium use, is kinetically controlled reaction, because these reagents, this butyl lithium reagent is very reactive. That's why they prefer to add at the active site. And additionally, okay, we will give example that will be better for you to understand. For example, let's take anisole, means phenyl methyl ether. We will do the ortho-lithiation on anisole. We'll add this NBB and this will result in the formation of this ortho-lithiation product at low temperature. Okay, this is lithium, this is, and this oxygen must have lone pair. How this reaction is happening? First, this anisole forms a tetramer. Tetramer means OPH, tetramer with butyl lithium. How? Last day I have explained this story that it forms a cube in presence of ether. Actually in hexane it is a hexamer, but in presence of ether it forms a cube where alternate lithium here, alternate position here, opposite alternate here and ultimately here. This is the lithium, and these alkyl groups remains in between. For example, Bu. For more understanding, please see my previous video, then you will have a better understanding. I just explained. In presence of ether, what happens? Ether coordinates to this, means O, this. Okay. Since there are 4 lithium sites, so 4 ether coordination will happen. So exactly this thing is happening here. Okay, so it forms a tetramer, then it reacts to form this lithium derivative. Okay, instead of that, if we add timeda means tetramethyl ethylene diamine. Okay, this reagent. How timeda reacts? If we take this lithium, butyl lithium in presence of timeda, it forms a dimer, and this dimer looks like here. These electrons, 4 electrons from one pair from here, one pair from delocalized over these 4 atoms. Okay, and this timeda coordinates from this side using the lone pair of nitrogen atom. Okay, this is so. In this way, lithium enjoys 8 electrons on its outside. So, if the reagent, if the timeda added, then even further low temperature. For example, if another reaction, if we consider timeda, then when in further low temperature, this reaction proceeds to give the same product. Okay, so now let's discuss about the transition state involved for this conversion. You can see this hydrogen is replaced by lithium. So and this butane is liberated. So 4 should be in transition state. This is hydrogen, this is, and previously in the drawing you have seen this butyl minus, Bu minus, and one carbon lithium bond form, that is carbon. So this carbon is from a benzene ring. So let's draw it in a different way. And since it is a directed ortho lithiation process, so the directing group X is here. For example, here it is oxygen, ON. Now these bonds are involved in transition state. Okay, this oxygen donation is not involved in the transition state. This lithium plus hydrogen, this, because due to the presence of electronegative oxygen, this carbon became delta positive. Consequently, adjacent carbon also feels little electron deficiency. Okay, and that increases the positive charge over this. As you know, in carbon hydrogen bond, carbon is more electronegative than hydrogen. That's why this reactivity regenerates. This helps to abstract the proton. First is coordination, second is little acidity. Okay, so in this is the transition state. So in this way, this electron is abstracted, and ultimately what happens? Previously there was this bond and this bond. Right now bond position will switch. This and this means lithium hydrogen, lithium carbon, and Bu hydrogen, lithium carbon, Bu hydrogen. So this is the transition state associated with this process. Okay, so let's discuss some other examples. So okay, after that, then we have to utilize this alkyl lithium. What happens if we provide any electrophile? It will react with this to form this OMe. In case of electrophile, if we take iodine is an electrophile as well as Lewis acid. So what happened? This bond attacks on the iodine, and what forms? This iodide, means E plus. Now there is a question. If we consider the electrophilic substitution of this anisole, it also produces this E. Then what is the point of using such a dangerous reagent? Last time I have explained that the accident associated with butyl lithium. So and this always such reactions require inert environment. I always don't write this, so you keep it in mind. All the butyl lithium reactions does under argon, and dry argon means gas may contain some moisture. Dry argon or nitrogen first, and second anhydrous solvent. I have explained in my previous video about this. Please see the videos to have a complete clarification. So dry argon and nitrogen in all reaction it is necessary. So I am not going to write in every case, but you keep it in mind. So why should we follow this process? It is true, question is true. So the thing is that if we do the electrophilic substitution along with the ortho, there will be some amount of para also. And depending on the substrate reaction condition, nature of electrophile, this ortho-para ratio will vary. Okay, but in this reaction we can selectively have ortho substituted. That is the beauty of this reaction. So keep it in mind. This ortho-lithiation means ortho-selective, although aromatic electrophilic substitution is both ortho-para selective. Okay. So this is. Let's take another example. Then I guess this concept will be cleared more. Instead of this single substitution, let's take a di substitution. For example, ON. Then if you do this N-butyl lithium reaction, then followed by reaction with iodine, what will be produced? OMe and iodine here. How? There is a two chance. For example, this center reaction can happen, and this or this both are same. This center could happen. But here, why this reaction is happening? Actually, this reaction happens because of the electron deficiency or the acidity of this proton. It is kinetically controlled, acidity of this proton. So, due to the presence of the minus I effect of this both two, this proton became more acidic, delta plus. So, chances that it will be abstracted more. Second point is chelation. Due to the chelation with this oxygen, this lithium, this lithium is attached and prefers to take this. Okay. Means what would be the chelation? Chelation is this lithium, this. Both. Actually, in case of both chelation, both bond will not strong because one bond will be little okay, means perfect, another will be little elongated. And here butyl group will abstract the proton. Okay. So in this way this happened. After having lithiation at this center, electrophilic substitution will happen exactly on this position. Okay, selectively. But as we have discussing in previous example, if we consider aromatic electrophilic substitution, which is little bit easier reaction, what will it produce? It will produce a means one respect ortho, one is beta. Why? Because this side is more bulky, so electrophile will not prefer to add here, because ultimately such type of sp3 hybridized intermediate is formed. Instead of that, this center is better because this center is ortho with respect to this, para with respect to this. So from both point of view this is stable, so reaction will occur here. So you can understand, to have a selective substitution, why this reaction is this directed ortho lithiation reaction is important. Okay. So now let's take another little tricky example. Why I am taking little tricky? I guess you will get it. How? Let's see the example. For example, just sometime before we have checked anisole, ONE. So let's put another group. Yes. Before going to that, okay, this is another group and let's react with bully. What will happen? See, this has a lone pair, this has a lone pair. So it can act as a directing group as well as this can act as a directing group. Question, what will be? So if it acts as a directing group, what will produce? Lithium attachment here. If other acts as protecting group, then lithiation will occur at this position. Now the question, where this lithiation will occur? Okay. So initially lithiation, if we perform the reaction in hexane, then in hexane, for example butyl lithium in hexane at low temperature and inert atmosphere, please keep it in mind, hexane, no, this product is formed, around 80% of this product is produced. But if we perform this reaction in presence of Timeda, what does it produce? Around 57% this and 7% this. So for your understanding, I will write the structure of Timeda again. This is Timeda. You look at it here, it will help you to remember. Okay. Okay. Sorry, it is not 57, it is around 55. 55 and 7. So this is Timeda. So why this is happening? Actually, there is a competition between this side, this position and this position. You can say, if we, in the first case, for example, hexane. In first case, when we are using hexane, we are considering this center. This center is more electron deficient, first, and second, we know that here oxygen will coordinate in case of this, and in presence of hexane, the reaction, sorry, I made a mistake. This center is more acidic, it is true, but in presence of hexane, what happens? This coordinates more, this lone pair. Why? Because if we check the donation capability of nitrogen versus oxygen, nitrogen has one lone pair, oxygen 2, but electronegativity of oxygen is more than nitrogen, means the oxygen prefers to keep the electron density on itself. So if we compare the donation capability, nitrogen is stronger donor than oxygen. And since in this medium only non-polar solvent hexane is there, no one is here to coordinate, then this will coordinate strongly, and this strong coordination will result 80% of this. Okay, 80%. But if we put Timeda, what will happen? This Timeda will form a dimer with this, and this Timeda will form a dimer. I have drawn the structure sometime before, so if you forget, you please check. And what will happen after that? After that, this one Timeda will eliminate, and this oxygen this will remain. This oxygen will coordinate and lithium will abstract this proton. Okay. So in this way, ortho-lithiation will happen at this stage, 50% conversion. So I guess you have understood, because when there is no Timeda, then this alkyl group, which is half part, you can say half part of Timeda, is coordinating due to the stronger coordination capability of nitrogen. But when Timeda is present, that coordination became less dominant as it contained di1, let's say chelating. Chelation is more stronger than single donation. So this lithiation happens here. And how this conversion are judged? Based on this reason? No. these two are reacted with electrophile E plus, and ultimate product form. Based on the product, it is judged that how much this ortho-lithiation happened for both sides. Okay. Friends, I shall stop the first part of this directed ortho-metalation here. So, in this discussion will continue in the second part, as the video will be very long. So, I request you to see the second part of this video to have a complete understanding. And if you like my video, please subscribe my channel Chemistry, the Mystery of Molecules. And if you like my videos, give us a thumbs up and share this video with your friends. So thank you everyone. See you in the next video.